RS latch, reset, set, latch. In this circuit, we will use two NOR gates. Input to first NOR gate is R, which is reset, and output of first NOR gate is QT, which is the present state. Output of first NOR gate goes into the input of second NOR gate, and output of second NOR gate goes into the input of first NOR gate, which is a feedback. And output of second NOR gate is QT bar. QT bar is complement of QT. QT is the present state and QT bar is the complement of present state. And input to second NOR gate is S or set. Now we can redraw this circuit and the circuit looks like this. R is set, R is reset, S is set, QT is present state and QT bar is the complement of present state. Here we are using NOR gate. So in NOR gate we have two inputs A and B and the output is A plus B bar, which is A NOR B. Now we can make the table for this NOR gate, and inputs are A and B and output is A plus B bar. If inputs are 0 0, then output is 1. For input 0 1, output is 0. For input 1 0, output is again 0. For input 1 1, output is 0. So we can see for this NOR gate, if any one of the input is high or 1, then output of NOR gate is 0 or low. And output of NOR gate is high if and only if all the inputs are low or 0. We will use this table to make the state table of RS latch. Now in state table we have QT, which is present state, S is set, R is reset. So we have three inputs and QT plus 1 is the next state. We can also represent present state and next state by Qn and Qn plus 1. Now let's see the first condition where QT is 0, S is 0 and R is also 0. R is 0, S is 0, present state is 0 and complement of present state is 1. Now QT and QT bar will go to the input. Now for first NOR gate, one input is high, so output is low, and for second NOT gate, both the inputs are low, so output is high. So next state is 0 and complement of next state is 1, which is valid state. So next state is 0. This next state is 0 here. Present state is 0, next state is 0. It means state is unchanged. Whenever the inputs S and R are 0, then next state is equal to present state. Now let's see the next condition. QT is 0, S is 0 and R is 1. R is 1, S is 0, QT is 0 and complement of QT is 1. Now QT and QT bar will go to the input. Now first NOR gate, both the inputs are high, so output is 0, and for second NOR gate, both the inputs are low, so output is high. QT is 0 and QT is complement of 0, which is 1, so it is a valid state. So next state is 0. QT is 0. So next state is 0. Here present state is 0 and next state is also 0. But R is high. It means whenever only reset is high, next state is reset or 0. Now let's see the next condition. QT is 0, S is 1, R is 0. R is 0, S is 1, QT is 0 and complement of QT is 1. Qt and Qt bar will go to the feedback. For first NOR gate, one input is high, so output is low. And for second NOR gate, again one input is high, so output is low. And Qt and Qt bar has to be complement of each other. So this is not the valid state. Now we will send these two zeros to the feedback or input again. Now one more time, let's see the output. For first NOR gate, both the inputs are 0, so output is high. And for second NOR gate, one input is high, so output is low or 0. So Qt is 1 and Qt bar is 0, which is a valid state. So next state here is 1. Qt is 1, so next state is 1. Present state is 0, next state is 1. Now here only set is high, so next state is set. Now let's see the next condition, where Qt is 0, S is 1 and R is also 1. R is 1, S is 1, Qt is 0 and complement of Qt is 1. Now Qt and Qt bar will go to the input. Now for first NOR gate, both the inputs are high, so output is low. And for second NOR gate, one input is high, so Qt bar is also 0, which is invalid state. So we will send these two zeros to the feedback again. Now one more time, let's see the output of the two gates. For first NOR gate, one input is high, so output is 0. For second NOR gate, again one input is high, so output is 0. So every time we will get the Qt 0 and Qt bar is 0, so which is invalid state. That's why Qt plus 1 or next state is invalid state. Now let's see the next condition. Here Qt is 1 and S and R both are 0. R is 0, S is 0, Qt is 1, Qt bar is complement of 1, which is 0. Qt and Qt bar will go to the input. For first NOR gate, both the inputs are 0, so output is high. For second NOR gate, one input is 1 or high, so output is low. So Qt bar is complement of Qt, so it is a valid state. Qt is 1, so next state is also 1. Here both the inputs are 0, so next state is unchanged. Next state is equal to present state. Present state is 1. Present state is 1, so next state is also 1 because both the inputs are 0. So state is unchanged. Now let's see the next condition. Here Qt is 1, S is 0, R is 0. So R is 1. R is 1, S is 0, Qt is 1. So Qt bar is 0. Qt and Qt bar will go to the input. For first NOR gate, one input is 0, so output is low. For second NOR gate, again one input is 0, so output is low. Qt and Qt bar are both zeros, which is invalid. So we will send these two zeros to the feedback. Now let's try one more time. So for first NOR gate, one input is high, so output is low. For second NOR gate, both the inputs are 0, so output is high. So Qt is 0 and Qt bar is 1, which is valid state. So next state is 0. Next state is 0. Here only reset is high, that's why next state is reset. Now let's see the next condition. Qt is 1, Qt is 1, S is 1, R is 0. R is 0, S is 1, Qt is 1, Qt bar is 0. Qt and Qt bar will go to the input. For first NOR gate, both the inputs are 0, so output is high or 1. For second NOR gate, both the inputs are high or 1, so output is 0. So Qt is 1 and Qt bar is complement of 1, which is 0, so it is valid state. So next state is 1. Here next state is 1. Here only set is high, that's why next state is set or 1. Now the last condition. Qt is 1, S is 1, R is 1. R is 1, S is 1, Qt is 1, and Qt bar is complement of 1, which is 0. Qt and Qt bar will go to the feedback. For first NOR gate, one input is high, so output is low. For second NOR gate, both the inputs are high, so output is again low. So we will send these two zeros to the feedback. Now first NOR gate, one input is high, so output is low. For second NOR gate, again one input is high, so output is low. So every time we will get Qt 0 and Qt bar is also 0, so which is invalid state. So this is the state table for RS latch. Now we will make the state equation for RS latch. For that purpose, we will use three variable K map. Three variable K map. In column we have Qt bar and Qt, and in rows we have S bar R bar, S bar R, SR and SR bar, and the numberings are 0, 1, 2 and 3, 4, 5, 6 and 7. Now we will shift this next state to the K map, and in place of invalid state we will use don't care. So these are the entries of K map. Here we have 2 ones and 2 don't cares. These 4 adjacent ones and don't care will make a quad, and one here at 6 and one here at 4 will make a pair. So one quad and one pair. So the state equation Qt plus 1 is S plus Qt R. From the quad we will get S, and from this pair we will get Qt and R bar. Qt and this has to be R bar, I think. This is bar. So state equation is Qt plus 1, which is S plus Qt R bar. Now we will make SR latch with active high enable signal. So for that purpose we will use simply the RS latch. This is the circuit for RS latch. Now we will use 2 AND gates at the input, and inputs to AND gate are R and S. Now what should be the another input? For another input we will use enable signal. Here E is enable signal. Output of first AND gate is R and E, and output of second AND gate is S and E, SE and RE. Now if enable signal is high, then these two E's will become 1, and RE is R and SE is S. So if enable signal is high, then this RS latch is enabled, or it will act as normal RS latch circuit. And if this E signal is low, then RE becomes 0, because E is 0, and SE becomes 0. In that case, this RS latch will be disabled. Now let's see the state table for RS latch with active high enable signal when enable signal is high. We have used 2 more columns, SE and RE. If E is 1, then SE is S, RE is R. So SR column and SE and RE columns are identical. So basically the RS latch is enabled if enable signal is high. So for 0, state is unchanged. When only reset is high, next state is reset. When only set is high, next state is set. When both the inputs are high, then next state is invalid state. When both inputs are 0, next state is unchanged. When only set is high, only reset is high, next state is reset or 0. When only set is high, next state is set or 1. When both the inputs are high, then next state is invalid state. Now, what if enable signal is 0 or the RS latch is disabled? If enable signal is 0, then SE and RE are 0 all the time. Because enable signal is 0, SE, RE are 0 all the time. So, if S and R both are 0 all the time, then next state is equal to the present state. Qt is always equal to Qt plus 1. So state is unchanged. The circuit becomes independent of inputs. So this RS latch will be disabled if enable signal is 0. And the expression for next state will be Qt. Next state is equal to present state. In the same way, we can make RS latch with active low enable. For active low enable circuit, we will use simple RS latch and the two AND gates at the input. One input is R, another input is S, and another input for these two AND gates will be E bar. We will use NOT gate here. E bar is the another input. So output of this NOT gate will be E. So output of first NAND gate is RE, first AND gate is RE, second AND gate is SE. And if E bar signal is low, then E is 1 and RE is R and SE is also S. So E bar, when E bar signal is low, then this RS latch will be enabled or it will act as normal RS latch circuit. And if this E bar signal is 1, then E becomes 0 and RE becomes 0 and SE also become 0 and the RS latch will be disabled. So this is the RS latch.